Download this code from codegive.com, link in the description below. To make C programs run faster, especially when dealing with tasks that can be performed concurrently, you can leverage the std async feature from the C++ standard library. While C does not have built-in support for asynchronous programming, C++ does, and std async is a powerful tool for launching tasks asynchronously. What is std async? Std async allows you to run a function asynchronously, in a separate thread, and obtain its result in the future. It can help you utilize multiple CPU cores effectively, especially for CPU-bound tasks or I/O-bound operations. When to use std async? 1. CPU-bound tasks, if your tasks are computationally intensive and can run in parallel. 2. I/O-bound tasks, if your tasks involve waiting for I/O operations, like file reading or network requests, which can be executed concurrently. Example use case: parallel computation of factorials. Let's say we want to compute the factorial of several numbers concurrently. Here's how you can do it using std async. Step 1. Include required headers. Step 2. Define the function to compute factorial. Step 3. Use std async to run tasks concurrently. Explanation of the code. 1 includes, we include IOStream for input/output operations, future for std async, and vector for managing collections of futures. 2. Factorial function, this recursive function computes the factorial of a number. 3. Main function. We define a vector of integers containing the numbers for which we want to compute the factorial. We create a vector of std future objects to store the result of each asynchronous computation. We loop through the numbers, calling std async to start the factorial computations asynchronously, storing the futures in a vector. Finally, we loop through the futures and call .get, to obtain the results. Ensuring thread safety. When using std async, you need to ensure that your code is thread safe, especially if multiple threads are accessing shared data. For instance, if multiple threads write to a shared variable, you may need to use mutexes or other synchronization mechanisms. Performance considerations. 1. Overhead, creating threads has some overhead. For short-running tasks, the overhead might outweigh the benefits of concurrency. 2. Resource limits, be mindful of the number of concurrent tasks you spawn. Too many threads can lead to contention and degrade performance. Conclusion. By using std async, you can improve the performance of your C++ programs by executing tasks concurrently. This approach is beneficial for CPU-bound and I/O-bound operations. Always ensure that your code is thread safe and consider the overhead of thread creation when designing your program.